Part 2 of Lesson 3 of Chapter 2 is on synthetic division. Part 1 we talked about using long division to divide two polynomials, and now we're going to talk about synthetic division. So if we do synthetic division, we have a divisor and a dividend. So what we need to do is we need to put a box, and the zero of your divisor, which in this case is -2, goes in the box. You list your coefficients. You can see that I'm missing an x to the third term. There's no x to the third term right there. So I need to have a 0 for a coefficient. -5, +5, and -2. Draw a line. And then how you do the synthetic division is you bring down the first coefficient, the 2. When it's below the line, you multiply it by what's in the box, put it in the next column. Then you add those columns, and then you do it again. So -4 times -2 is 8. 8 added to -5 gives you 3. 3 multiplied by -2 gives you -6. 5 and -6 added together gives you -1. -1 and -2 adds together, multiplies to give you +2, and then that adds to give you 0. So when you get a 0 at the end, or whatever number you get at the end, that represents your remainder. If we get a 0 at the end, that means it divides evenly. And so our answer when we divide these is going to be 2x to the third minus 4x squared plus 3x minus 1. That's going to be the quotient. So we get that from the resulting coefficients at the bottom of the synthetic division. Here's another example, same kind of problem. We're taking a third-degree polynomial and dividing by a linear binomial. So the number we need to have in the box is +3 since we're dividing by x minus 3. My coefficients are 4, 3, -1, and 8. So now doing the synthetic division, we bring down the 4, multiply, add, multiply, add, multiply, add. The last number represents your remainder. So in this case, our final answer is 4x squared plus 15x plus 44, and we take the remainder and we put it over the divisor, which in this case is x minus 3. So this would be the answer we get when we use synthetic division dividing those two polynomials. Next I want to talk about the remainder theorem. The remainder theorem simply says that a polynomial f of x is divided by x minus c, then the remainder is f of c. So here's what that means. You can see on this example that we just got done doing, we took the third degree polynomial, we divided by the first degree polynomial, x minus 3. So if we didn't care about the quotient and all we cared about was getting the remainder, this is how we could do it. Since we're dividing by x minus 3, we could put 3 into the function. So if I put 3 into the dividend, should get the same result. So this gives us 108 plus 27 plus 5, which is 140. You can see that's the same result. So that's the remainder theorem. The next one I want to talk about is the factor theorem. Well, the factor theorem says a polynomial f of x has a factor x minus c if and only if f of c equals 0. So as an example, let's just use numbers. What's 20 divided by 3? That's equal to 6 with a remainder of 2. So do those two numbers divide evenly? No. So since they don't divide evenly, is 3 a factor of 20? No. Let's try it again. Let's take 20 and let's divide by 4. That would give us 5 with a remainder of 0. Well, if the remainder is 0, does that mean that they divide evenly? Yes, it does. If they divide evenly, is 4 a factor of 20? Yes, it is. So the factor theorem just simply says that if you divide and get 0 for a remainder, that means what you divided by represents a factor. So the last type of problem says, use the factor theorem to determine if the binomials given are factors of the function. So I need to say yes or no on this. I'll need to say yes or no on this factor. Well, the easiest way to do that is to divide and see if you get 0 for a remainder. So Let's divide by x minus 1 using synthetic division. I'll put 1 in my box. My coefficients listed out here. Doesn't look like I'm missing any coefficients. Let's see if we get a 0 at the end. That's a 50 right there. I should probably make that a little bit more clear. There it is. So since we did not get 0 at the end, we're going to say that x minus 1 is not a factor. Well, now let's do the same thing. Let's test x plus 3. If we're going to test x plus 3, we need to have a negative 3 in the box. List out my coefficients. None missing. Let's see if we get 0 for a remainder. Sure enough, we do get 0 for a remainder. So we can say that x plus 3 is a factor. And then, read the very last sentence. It says, use the binomials that are factors to write a factored form of the function. So, what I'm going to do is I'm going to rewrite the original function in a factored form. I'm going to use x plus 3, and the rest of it would be 4x to the third plus 9x squared minus 2x plus 1. And where I got that is from the resulting coefficients of dividing by x plus 3. So that's what I'm going to have you go about. The last example here is using the factor theorem to determine if the given binomials are factors. You're looking to see if you get a 0 for a remainder. If you do, it is a factor. And then lastly, write it in a factored form. Last thing I want to go through is, on this problem, this is one of your homework problems that you should have done via long division. And here it is. Using long division, you should have gotten a quotient of 3x to the fifth plus 3x to the third minus 6x squared minus 2x plus 4 with a remainder of negative 2. But since we're talking about synthetic division, this is a problem where we could have done with synthetic division. If we do this with synthetic division, we have to have a positive 1/2 in the box. If I list out my coefficients, doesn't look like I'm missing any terms. Should get a negative 2 at the end for my remainder, just like I did with long division. Sure enough, we get the exact same remainder. But look at these resulting coefficients. Notice how they're not the same as the coefficients we have in the quotient when we use long division. So, here's what I'm telling you, is that if you do synthetic division and you have a fraction inside your box, you have to divide each of these resulting coefficients by the denominator in your box. So that's how I'm going to get 3x to the fifth, 0x to the fourth, 3x to the third, minus 6x squared, minus 2x, plus 4. Now you don't divide the remainder, so we're still going to use the negative 2 over the 2x minus 1. So that would be the result. That's the same answer we get using synthetic division as we get using long division. So remember to do that if you've got a fraction in your box using synthetic division.